Hello students. In Maxwell syllabus, we have the module Electromagnetism and Dielectric Magnetic Properties of Materials. Today, we discuss dielectric materials. The first thing that we have to know, what is dielectric material? Dielectric material is a special substance that under almost all conditions is insulated and has ability to be polarized and can persist electrostatic field for a long time in it. Two things are very important. One is ability to be polarized and can persist electrostatic field for long time. Common example of dielectric material is glass, mica, dry air, etc. Dielectric substance is characterized by a parameter known as dielectric constant. Now the question is, what is dielectric constant? Dielectric constant is the ratio of permittivity of the substance to the permittivity of the free space. If the permittivity of the substance is epsilon and the permittivity of the free space is epsilon 0, then dielectric constant is written as epsilon by epsilon 0. Now we discuss about the types of dielectric materials. There are two types of dielectric materials. One is polar dielectric and other is non-polar dielectric. In polar dielectric, the center of mass of positive particles does not coincide with the center of mass of negative particles. When we apply electric field, they become polarized. That means align themselves with electric field, shown in this figure. Example of polar dielectric are water, carbon dioxide, etc. Now, non-polar dielectric material. In that type of material, the center of mass of positive particles and negative particles coincide. When electric field is applied, they become polarized, shown in this figure. This is the absence of electric field and this is the presence of the electric field. Example of non-polar dielectric is hydrogen, nitrogen, oxygen, etc. Here we use the term dipole moment. Now my question is, what is dipole moment? Let us consider the same amount of charge, one is positive and other is negative, separated by a distance d. Here is a two charge, this is positive q and negative q, the amount is same and the distance separated is d. Then what happens? In this situation, dipole moment generates. A dipole moment is product of the magnitude of the charge and the distance between the centers of the positive and the negative charge. So mathematically, we say that the dipole moment is equal to charge into distance of separation. Okay. Now we have to know what is polarization density vector. It is defined as the electric dipole moment per unit volume and it is mathematically written as the polarization density vector is equal to number of dipole per unit volume. If the number of dipole moment per unit volume is n, then that polarization vector is equal to A into the dipole moment. We already defined what is dipole moment, that is small p. So This is mathematical expression of polarization density vector. Now we have to know the term electric susceptibility, which is denoted by chi. What is it? We know polarization depends on electric field. So, when we apply electric field, the dielectric material gets polarized. So, polarization density vector or the polarization vector is proportional to electric field. Mathematically, polarization vector is equal to electric susceptibility into permittivity of free space into electric field. This is the mathematical expression of the electric susceptibility, which is depends on the polarization vector as well as electric field. Another parameter is atomic polarizability, which is denoted as alpha. What is it? The atomic polarizability. The same argument is applicable here. Dipole moment of an atom of dielectric material is proportional to the applied electric field. So, mathematically, the net induced dipole moment of an atom of a dielectric substance is placed in an electric field is proportional to the electric field. So, mathematically, the dipole moment is equal to alpha, that is atomic polarizability, into the electric field. Another very important term is electric displacement vector, which is denoted by the capital D. It is defined as the number of lines of force crossing normally per unit area of surface. Mathematically, the electric displacement vector is epsilon is equal to epsilon into E, that means permittivity of a substance into the electric field. And also, this is very important relation, that is electric displacement vector is equal to the epsilon 0, that is permittivity of a free space into the electric field, and plus the polarization vector. The relation between electric displacement vector and electric field and the polarization vector. So, this is the relation between three parameters. That means one is electric displacement vector, one is electric field, and other is polarization vector. In dielectric material, this is very important relation. Now, it's time for derive some relation. First, we derive the relation between dielectric constant and the electric susceptibility. So, we already know the equations. What is that? First thing, the displacement vector is proportional to or equal to epsilon into E. That means permittivity of a substance into the electric field, which is also written as epsilon 0 K, that means dielectric constant, into E, because K is equal to epsilon by epsilon 0. And also we already know that D is equal to epsilon 0 E plus P. And from the definition of the polarization vector, P is equal to electric susceptibility epsilon 0, that means permittivity of a free space, and the electric field. So in this equation, that is D is equal to epsilon 0 E plus P, we substitute this D by epsilon 0 K into E. This is as usual, and this P is substituted by this electric susceptibility epsilon 0 into E. Cancelling the E and epsilon 0, we get the dielectric constant is equal to 1 plus electric susceptibility. So, this is the the relation between the dielectric constant and the electric susceptibility. Now, the relation between electric polarization and the dielectric constant of a dielectric medium. Already we know that D, that means electric displacement, is equal to epsilon 0 K into E, and this is the well-known equation, that is D is equal to epsilon 0 E plus P. In this relation, we have to relate P and the dielectric constant. That means electric polarization and the dielectric constant. So D is replaced by epsilon 0 K E. This is, and this right hand side is as usual. And rearranging that, we get P is equal to the dielectric constant minus 1 epsilon 0 E. So this is the two relation which is very important. One is relation between dielectric constant and the electric susceptibility, and the other is polarization with the dielectric constant. Okay. In this slide, we have to know the Clausius-Mozzi relation. This relation actually connects the relative permittivity of a dielectric to the polarizability of atoms per molecule in that dielectric. Mathematically, it is epsilon minus 1 by epsilon plus 2 is equal to n alpha by 3 epsilon 0, where epsilon is a relative permittivity and alpha is the polarizability, n is the number density. And we get the relation between the relative permittivity, polarizability, and the electric constant or the permittivity of a vacuum. This is all about the dielectric material. Okay. Now we have to know the Maxwell's equation. These equations are basic equations of electromagnetic. There is 4 equations under Maxwell's equation. One is Gauss Law of Electrostatic. There is 2 forms. One is differential form and other is integral form. The first equation, that means Gauss Law in electrostatic, the differential form states that divergence of electric displacement vector, that means D, is equal to charge density, that means rho. So it is the differential form of Gauss law in electrostatic. Whereas what is the integral form? Integral form states that the surface integral of electric displacement vector, that is D dot ds, is equal to the volume integral of charge density. Okay, there is a 2 form. One is differential form and other is integral. What is the physical significance? Physical significance of the Gauss law of electrostatic is the electric field line starts from positive charges and end at negative charges. This is the first thing. Secondly, this equation does not depend on time, and the charge density is a scalar quantity because it is a divergence. Second law of Maxwell's equation. This is known as Gauss law of magnetostatic. What is the differential form? Differential form is divergence of magnetic flux density or magnetic induction vector is equal to 0. Whereas the integral form is surface integral of magnetic flux density vector is equal to 0. This is the differential and this is the integral form. What is the significance? Physical significance is, firstly, an isolated magnetic pole cannot exist. Secondly, this equation does not depend on time. Thirdly, there is no source or sink for magnetic lines of This is the all about the Gauss's law of magnetostatic, that means second law. Third law. Third law is Faraday's law of electromagnetic induction. The differential form states that the curl of electric field, vector is equal to the negative time rate of change of magnetic flux density vector. And the integral form is the line integral of electric field vector is equal to negative time rate of change of the surface integral of magnetic flux density vector. This is the Faraday's law of electromagnetic induction. What is the physical significance? The physical significance is electric field is produced due to the change of magnetic flux with time. And this equation depends on time. First two equations, it is independent of time. But the third equation is the depend on the time. Fourthly, modified form of Ampere's law, which states that the curl of magnetic field vector is equal to the sum of conduction current density and displacement current density. This is the differential form. Whereas the integral form defines or states that the line integral of magnetic field intensity vector is equal to the sum of conduction current and the displacement current. The physical significance is magnetic field is produced due to the current density of the magnetic flux with time, and this equation is also depends on time. So the first two is time independent, but the third and fourth is time dependent equation. So in this video we covered dielectric material and the Maxwell's equation.